Hey everybody, so we're looking at seeing if this soccer player can get this ball over the fence here. He's 20 meters away. He's able to kick it at 15 meters per second. And the angle happens to be 40. And so what we'll be able to do is see if it gets over this fence. It's 2 meters tall and is 20 meters away in this direction. So put 20 meters here. So remember, for any projectile motion type question, it's pretty good idea to break your x and your y components up. So I'm going to get some sort of initial velocity x, which is 15 cosine 40. And then I'm going to get some initial velocity y, which is 15 sine 40. Remember that y also gets a negative 9.8 meters per second squared. I won't write a lot of units on here to not clutter up the page. Let's see, what else can we get? Here we've got a final velocity in the y direction. We should be able to get a y direction final velocity. We could get a time, and we could get a delta dy. Over here, we could get a time and a delta dx. Well, if you look down here, we've got two delta dy and a delta dx. The question is which one is which? Well, there's two approaches to this question. One is where you make 20 equal to delta dx, and then you solve for delta dy, and you let that be a variable. And that's the one I'm going to do. So I'm going to basically say that this is delta dx, and even though this is a delta dy, I'm going to keep this a variable. I'm basically going to say, all right, I'm going to set the horizontal distance to 20, and then I'm going to discover what delta dy is. And then once I've discovered that value, I'll compare it with our 2 meter net or fence. Okay, and see if it's tall enough, etc. The other way of doing this is to do it the other way around. I actually force delta dy to be 2 meters, and then I let delta dx be a variable. And it doesn't matter how you do it, as long as you choose one to remain a variable and the other to remain not a variable. Okay? And so I'm going to basically say, all right, I'm going to set my delta dx to be 20. And that way I'm able to find my time. This is a bit of an easier way because this is a easy formula. Remember, Vix is equal to delta dx over time. And so if I solve for time, I'm going to get time is delta dx over Vix, which happens to be 20. What is it going to be? 20 over 15 cosine 40, which is about 1.074. Okay. Now that I have my time, 1.74 seconds, I'm going to go ahead and put it here. 1.74 seconds. And then I'm going to solve for my delta dy. And then I'm going to see to myself, is this delta dy above 2 meters, in which case the ball makes it over the net, or is it below 2 meters, in which case it does not make it over the net. All right, so now we've got a delta dy, and we're going to solve for it with this handy formula, which is the VIY times time plus 1/2 g times time squared formula. That's a nice one. And so I know that my delta dy is going to be 15 sine 40 times 1.74 plus 1/2 times a negative 9.8 times a 1.74 squared. And I solved all these beforehand. This is going to be 1.94 meters. Okay. And so basically what happens here is, no, it doesn't get over the net, because after it travels 20 meters, the thing is not 2 meters in the air. It's only 1.94 meters in the air. And so it will just like barely hit this fence and not make it over the fence. Okay.